الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل.
Hello everyone. Thank you to be with me during my session today. I'm Kenni Konate, a master graduate in data science and AI, computer vision engineer. Today in our session, we will predict heart disease using logistic regression algorithm. So I want to give a little information about logistic regression and why I use it. A logistic regression is a supervised machine learning algorithm. In supervised, attempts are done to find the relationship between the independent variables and the dependent variables. The independent variables, we mean input attributes that we use, and the dependent variables, we mean the target attributes that we use. Why I use a logistic regression here? We will be dealing with binary classification, so that's why I use logistic regression here, because when logistic regression models are used to study effects of predictor variables on categorical outcomes, and normally the outcome is binary. If the outcome is binary, so we call it a binary logistic model. And now we will go to the code. So here, as you see, firstly, I import the libraries. I import NumPy pandas from scikit-learn. Scikit-learn model, I import train test split to split my data, and from sklearn, I import logistic regression, and from sklearn metrics, we import accuracy score to show our model accuracy. Yeah, and here, as you see, there is a code here. This code, we use it when we want to import our data from the drive. So here I will mount my Google Drive, then I can use the data from there. But now I'm not using this one. I import my data here. So as you see, the hard data sets. So from here I will use it, and yeah, that's why I copy only the path, and the path is here. Yeah, we will run it. As you see in the comments, loading the CSV data to a pandas data frame. With shape function, it will give me a number of rows that I have in my dataset and the number of columns that we have. Yeah, and here we used head function to show the five rows, the five first rows. If I didn't put any number, it will only give me the first five rows of the data set. But if I give a number like 10 or 15, so it will show me the number of rows that I gave here. Okay, just make it like this. Okay. Here I used tail function, and with tail function it will show us the five last rows from our data set if we need to see it, of course. So here also, if I didn't give any number, if I give a number, let's see, 5%. So yeah, it works like the head function, but only with head we can have the first five rows. With tail we have the last five rows. We don't give any number. Here I used info to give me more information, to see more information about my data set. So as you see here, I have all the columns that I have in my data set, age, sex, all of them. And here the data type, and even it counts the non-null number. Here with is null and the sum, we check the missing values. If we have any missing values in our data, as all of them are 00, so it means that we don't have any missing values in our data. Yeah, with the describe function, we have the statistical measures. As you see here, the count, mean, standard deviation, minimum, maximum. Yeah, if there is a need to see them, of course. So with the describe function, you can have all these measures. Here, I want to check the distribution of target of a variable. We know that in our data set, it's a hard data set, so we want to know if the person has a heart disease or not. And with the value counts, here it counts for us to how many numbers of 1 and how many numbers of 0 in the target variable. So as you see here, 165 with one variable and 138 with 0 variables. 1, it means the person has a heart disease. 0, it means the person doesn't have heart disease. And here I wrote it as to make it more clear. Yeah, here we come to splitting the features and targets. So we will put the features in X variable and the target in y variable. So I will run it. And you can see here. Yeah, now I want to share with you the link of our dataset because I import the dataset from Kaggle. Let's share it with you. Here, as you see, in the X, we have now all the features, the other columns, without the target column. So we have 303 rows and only 30 columns because the other column is now in white, as you see here. And of course here also we can see the data type of our variable. And now I'm going to splitting the data into training data and test data. In this project, I give 80% to the training data set and 20% to the test data set. So here we split it. Here I give the number. So as you see here, 0.2. So it means 20% will be in the test data set, and of course the 80% will be in the training data set. So of course you can change it to 3 if you want, like 70%, 30%. So whatever the number that you want here. But of course we need to, in general, we split it in 80% and 20%, or we use validation clause. Here, after splitting the dataset, we can see here in total how many rows we have, how many columns we have in X variable, of course. And here now how many rows we have in train dataset, how many rows we have in the test dataset, and of course the columns are always 13, because the features are the same in all of them. Now we will create our model with logistic regression. So as you see here, I will logistic regression, and after that we will train our model with fit function. So we give X train and Y train. And after training our models, we will see now the accuracy of our model. So on training data, we have is 85%. Here, of course, we used scikit-learn as, and it's a Python library. So we will share the link of it also. Yeah, yeah. After that, we will see the accuracy on the test data. And we will print the accuracy on test data. So here, the test the accuracy on test data is 81%, and it is the accuracy of our model. Here we can validate our model with building a predictive system. So we can give the attributes, the features, and to get the result if the person has heart disease or not. So here, as you see, the person has heart disease, but I can give another data from our validation data to see. Yeah, I can give an information about if our target variable is not a numerical. So if it's not a numerical, mm, you can use label encoder. Here I will give another number to see. To test our model to see. In the validation data that I have, it should give it as a 0, so the person doesn't have a heart disease. Yeah, you can test it also with another one. So, yeah. that's it. Yeah, and with this one, as you see, yeah, here there is a warning, but it's not an error, so that's why I left it here. Here, here there is the references to the data sets that I used during this session, and all of the other references are here. So thank you to be here with me during this session. We will see if you have any questions. So if you have any question about hard disk prediction with logistic regression, it will be welcome. Okay, as there is no question, so thank you for today. Hope that it's informative for you.